for theory of computation for non-deterministic finite automata, Unit 1. I am Dr. P. Ezhumalai, Professor at CS Department, RM Engineering College. Let us see the example for Unit 1. Second example. Non-deterministic finite automata. Non-deterministic finite automation is, of course, non-deterministic. It implies that machine can exist in more than one state at the same time. That means you are giving one input, it will be transmitted more than one state. One input can be transmitted more than one state. Transition could be non-deterministic. For example, you are giving input 1 in the QI, one goes to QJ, another one goes to QK. So this example we called as a non-deterministic finite automata. The definition of non-deterministic finite automata. So number of five tables contains the machine. So Q is a finite set of states. Summation is a finite set of input symbols. This means input alphabet. Q not the starting state. F is a set of accepting state, final state. Delta is the transition function, which is mapping one state to another state. For example, Q summation equal subset of all the Q sets. And NFA is also defined by 5 tables, which is called Q summation, Q naught, F and delta. How to use an NFA? The input we are giving, input we are called as a summation star. Is double is accepted by NFA? Yes. If the start state, the Q naught state, the start state. For every input symbol, the sequence of W do. Determine for all the possible next states from the current state, the given current input W and the transition function. If after all the symbols in W are consumed, and if at least one of the current state is a final state, the input will be accepted. Otherwise, input is not accepted. That means rejected. Example 1. Construct a non-deterministic finite automata for the language L, which accept all the strings. The third symbol from the right hand is always A over the input summation A comma B. Let us see that. So we are giving input A comma B. Suppose the star A is the starting state, D is the final state. Between B and D, C is intermediate state. You are giving input A, it goes to A to B. You are giving A or B from B to C. A or B, it goes to B to C to D. You are giving right from there, their symbol is A, right from the right side. From the left to, always start from the left to right. Here we are starting from the right side, left to either first symbol of the right hand side is A or B. Second symbol right hand side from A or B. The third symbol must be A. So then only it starts from A to B. The third symbol from the right to left starts A means then only reaching the final state. Otherwise, it won't reach the final state. Example 2. Design a non-deterministic finite automata with input symbol 0, 1, in which double 1 is followed by double 0. This is the double 1. First input symbol is double 1, double 0. So Q0, Q1, Q2, Q3, Q4, 4 states are there. Okay. It is non-deterministic. Suppose you are giving 1 in the input in the Q0, it goes one state will goes to Q0, other one goes to Q1. Similarly, double 1 goes to Q0 to Q1, Q1 to Q2. Similarly, input you are giving 0 means Q2 to Q3. Another 0 goes to Q2 to Q4, goes to final state. So that means what? Double 1 followed by double 0 is the final state. This is a non-deterministic finite automata example. NFA to DFA construction example. How to construct NFA to DFA? You see that example. The W is the word. W ends with 0, 1. NFA is given below. Okay. Q0, Q1, Q2. Q0 to 0, 1. Q0 to Q1 self-load. We are giving 0, goes to Q0, and then also Q1. We are giving 1, the Q1 goes to Q2. This is NFA table. 2 tables are different. We are giving Q0 0, it goes to two states. Q0, Q1. If you are giving 1 in the Q0, it goes to Q0. If you are giving 0 in the Q1, it is null state moving. If you are giving 1 in the Q1, it goes to Q2. Q2 is the final state. So no more movements are from the Q state. This is a NFA table. How to convert this NFA to DFA? First, enumerate all possible subsets. We have to construct the subset of the states. So 2 states are there. 2 states into 2 power Q. 8 possible states will be generated. The first is called 5, Q0, Q1, Q2. All the 3 states possible. The combination of other 3, Q0, Q1, Q0, Q2, Q1, Q2, another Q0, Q1, Q3. So all the possible subsets you have developed here. Then it starts from the Q naught. So first, what is the input? Determine the transitions. First, Q naught 0. Q naught 0. What are the states or possibility? One is goes to Q naught, another one goes to Q1 in the diagram. So the Q naught Q1 is combined in Q naught input 0. Similarly, Q naught 1. Q naught 1, it goes to only Q naught. Q naught 1, it goes to Q1 only. So no other states are input transition from the Q naught, from the Q1. So input, no input moment are 0. The Q1 1 goes to Q2. Similarly, Q2 0 null state moving. Q2 1 null states moving. Similarly, other subset Q naught Q1, you have to combine together. Q naught 0 union Q1 0. Combining these two, it goes to Q naught Q1. Similarly, Q naught 1 Q1 1 is combine of this union, goes to Q naught and Q2. Similarly, star is a final state which contains a Q2. All the states are called as a final state. Here, this state Q naught Q2. First input 0, combination of 0 Q naught 0 Q2 0. It goes to Q naught and Q1. Similarly, Q naught 1 Q2 1 goes to Q naught only. So Q1 Q2, the transition 0, it goes to null state. Q1 Q2, input 1 goes to Q2. Similarly, Q0 union Q1 union Q2, input 0 goes to Q0 Q1. Similarly, Q0 union Q1 union Q2 union 1, it goes to Q2 Q1 Q0 Q2. So this table is called as now DFA table. Retain those only states reachable from the Q0. The states will be listened. So reachable state from the Q0. What are the states are reachable from the Q0? Q0 is there. Q0 only state. The other states not reachable from the Q1. Q0 0 and 1. Then Q0 1 and 0. Q0 Q2 0 and 1. So other states are not reachable from the state Q0. So that all removed. Remaining states only they are combined. This is a converted table for DFA from the NFA table. This is a diagram for DFA. To avoid enumerating all the power sets to do this method. Thank you.